Okay, continuing, we are now looking at what we call longest matching. So basically, longest matching is used to compare destination networks, therefore deciding where to forward my packets edu if we have multiple routes that could apply to our destination network kwatoda kuendesa packet. So we're going to see it will be sort of a bit-to-bit comparison, trying to find out the route which matches the most bits, therefore the route richazoshandiswa to get to the destination network. Router process yarinoita if a packet is destined for the network B, parinobva panapa richisvika paruta yekutanga iyi, ruta iyi inotarisa table yayo yotarisa kuti destination network ichi mutable munomu munenge mune maroutes. Destination network apa inofanira kumecha maroutes ari mutable. If it does not match, then packet roro rinodropwa, or mostly panoiswa inonzi a default route rinobva rasendwa to the default route. But if there is a match, if there is a route to match at the destination network, then that's how it gets forwarded to B. So the first process in Etika is matching the destination network name routes at negative routing table. So we have other cases, yekuti ma routes, my entries are in routing table. Akada kufanana the destination network here. In this example, you can see our packet is destined for that host 172.16.2.1. Then you can see tine routing entries at now 172.16, 172.16, 172.16, 172.16. Ese akada kufanana nekuri kuenda our packet. But which route does our router forward to? Router redu rinoita inonzi longest matching. Kunenge kune longest match ndo kunoendeswa packet redu. So in this example, longest match yedu inenge iri papi. You look, unoisa IP address yako ku binary. So we didn't put binary here because I think it's the same panap. Match iripo pesa up. But kutangira panapo kuenda uku, you're going to realize that match yedu ichatisiyane. So this is binary value 2-ish. This is binary value 1. 2, 1. Do IP address here. Then toisa 172.16.1.0 do irapa. Toisa ku binary as well. Subnet mask /24. Then totora imwe 172.16.2.0 ndo irapa 2 yarapo .0 yarapo /24 do ish. The other one it's /16. That's why murikuona iri kugumira panapa. So longest match yedu ichatora mabits api. Ichatora this one akafanana. Aya akafanana. Let me take, I think kusvika up. Akafanana. Akafanana. Aya akafanana. But kuzobva panapa kuenda uko ira rinofanana. But akafanana neapi arapa. Meaning route iro ndo rine longest match, meaning route iro ndo richashandiswa kuforwarda our packet to the destination. So the longest matching is basically used to decide if we have multiple routes akada kufanana newa destination network, which of those routes will we choose? We choose route in the longest matching. Another example, the longest matching. So we can see destination IP address here in the ish 192.168.2.2. Then routing table here in 3 entries are up. How do we find longest match here? Tinoisa tunoshandisa a little bit of binary. So ndikatotarisa 192.168.2.2 ndo IP address here. I think we need this. Just a minute. Hopefully this opens quick. Right. Okay. Right. So we have my networks edu. Let me see. 192.168.2.2. That's page 22. Let me try to find page 22. 4.22. All right. All right. We have my networks destination IP address here is 192.168.2.2. So this is our destination IP. Then my entries here, entry number 1 is 192.168.0.0/16. Then we have 192.168.2.0/24. Then we have 192.168.3.0/24. We want to find the longest match. Longest match here by doing this. If we look at this part ish, yakafanana kwese. So we are good. Ese anokwanisa kushanda. Then tikatanga tarisa part ish, we have to convert that to binary tinyatsoona what's happening there. So convert a 2 to binary. I get something like this. 1 2 3 4 1 2 6 8. I think that's 2 for you. 1 2 3 4 5 6. That's 2 for you. Tikatotarisa matching iri kuitika panapa. I think iri kumecha kusvika akaisweresa. I think let's just do it. Let us not be lazy. 0 0 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. That's 8. Then this one .2.0. So it's 1 2 3 4 5 6. Then we have 1 2 3 1 2 3 1 2. The other one is .3.0. 1 2 3 4 5 6. I think this is 3. 1 2 3 4 5 6 7 8. So this is /24. The other one is /24 as well. This one is /16. Right, but the longest match here /16 ish, ndotoyabudisa ish, because the worst portion iri kugomera ipapa, but we can see worst portion yedu panapa is still there. Ikapinda /16 inenge yakanzora zvinhu zvakawanda, so that one cannot be the longest match. If we take a look at this one, iri kumecha this part yese octet yese iri kumecha ne-ish. If we look at this part, iri kumecha kusvika panapa, then this part has kumecha. So evidently tikatotarisa the longest match inosara iri ino. It's very simple actually. You are just patching mabits kuti from IP address yandinayo and from entries yandinayo ndikamecha mabits one by one kwandinowana the longest match ndekupi. Therefore route iroro, that's the route which will be chosen to send my packet to the destination network. Simple logic. So that is what the longest match matching is basically. It's a method that is used by a router to choose the destination network yedu tinosvikako tichishandisa route heap. I won't be doing another example. Let's go directly to route-based forwarding process. What do we have here? Destination IP is 40.0.1.2. It should be on this network. How do we get there? Right. So I think in this example, this is sort of a summary of what we've learned so far. We're trying to figure out if we are sending information from PC Irpanapai to this destination network, what basically happens. So Sirikuitika, my routes edu ese, I think they are installed in my routing tables. We have routing table ish, here router 1 irapai directly down. We have routing table here 2, then we have routing table here 3. So packets edu richipa panapa, rine destination irapai. Parnosvika parouter rinori. Router rinori will look at its routing table. Then you can see destination network here irapai. Next hop IP address 20.0.1.2 ndo irapai. Exit interface redu ndo irapai. So information ikabva panapa ichiuya up in a destination irapai. It will be forwarded out, routed out this interface to this IP address. Ndo masvikira inosvika panapa. Ikasvika parouter inoi, the destination network haichinji, yotariswa futi mutable, then yakubuda via this interface ichisvika pana next hop 30.0.1.2 ndo irapai. Then kana yasvika panapa tikatarisa murouting table again, our next hop inenge yakakusanzi next hop because it's a directly connected interface, ndo inenge ya last hop redu. Per table, yes, it's next hop, but it's no longer the next hop. This is our last hop. Directly connected interface. ARP of a performer, then information of a to the destination device. I think that's the process relating a route-based forwarding process. Taking a look at the routing table, what is the exit interface, what is the next hop IP address, then you go to the other router up until you get to the last hop information of your sender to a destination. Summary of the routing table. When a router obtains routes the same destination, same network, we are not going to summarize. Packets are forwarded hop by hop. Therefore, all the routers along the path from the source to the destination must have routes destined for the destination. Otherwise, packet loss occurs. If packet rangu rikasvika panapa, routing table entry irimo yobva yaforwardwa kusvika panapa, then painosvika panapa murouting table ichi chinenge chisimo ichi, what happens? Packet rinodropwa because my routes andinawo, they don't match my destination, they do not match my destination IP address. So that packet will be lost. It won't be dropped automatically, but it will tenderera until, I don't know if we did my TTLs, zero, then it gets dropped. That's how you get packet loss, because routing table meaning that entry inenge iri kumecha your destination network. That's a problem. Moving on to application scenarios of static routes. So we've dealt with my direct routes. We've defined my static routes, manually configured. Now looking at application scenarios, where do we apply those static routes? My static routes, they are usually applied to my small networks. Very easy to configure. They are very stable, very simple. They don't waste a lot of memory. So for small networks, very useful. We have attended my stub networks as well, very useful. My networks where we only have one exit interface. My static routes, they are very useful. We have my default routes. Default route rekuti if a packet doesn't match anything in routing table, then it is forwarded to a default static route. Iyoyo route iroro, it's usually a static route. Why? It's simple to configure. Destination yedu tikuziva kuti is outside our network, usually the internet. We use static route to configure that. Tine backup routes, floating routes, floating static routes. So panapa small networks, look at my stub networks, look at my default routes, then look at my floating routes. I'm a backup. My type of my routes are, they're usually my static routes because they're easy to configure, small networks, less processing. Then the disadvantage of static routes is they cannot automatically adapt to network topologies and so require manual intervention. In the example, Iripopa diagram, static route readily configured, we have routing table RTA. You can see this is a directly connected interface doing a network irapa. But for us to get to this remote network irapa, how do we get there? To configure a static route where we tell this router kuti kana uchida kusvika kuno, you go via the exit interface irapa. It's not there. So if there was an interface here, it will say gig 000. Then our next hop IP is this address irapa. Do address irapa. I think taita my examples akawanda, and I keep mentioning kuti exit interface iri papi, next hop IP address iri papi. I hope parobatika kuti chinonzi exit interface chi and our next hop IP address chi. That will become very important. So example irapo, there's a static route iro configure where you manually configure, manually tell RTA kuti kana uchida kusvika panapa, buda neapa, obva wasvika panapa. Then ukasvika panapa, iri is directly connected, therefore inotoziva kuendesa panapa. That's the logic. The configurations, those are the commands dzinoshandiswa, and it's very simple. For a static route, you have the destination network panapa, its mask or its mask length, then unoisa the next hop address, or unoisa the exit interface. Okay, it's here. Or unokwanisa the exit interface in this example. At times, unokwanisa kuisa zvese the next hop address and the exit interface. In Cisco, we call this a fully specified route. This one is a directly connected route. Directly, I think so. Russian's exit interface, directly connected route. Then this one, it should be next hop route, I think. Not so sure here. But that's how we configure Maraos Edu on Huawei devices. On that note, I'm going to share a folder in a software which is used to simulate Huawei devices. It runs is it the NSP? NSP2, I think. I think that's where we'll do our practicals using that software. Do but introduce kuma commands esarapa. But it's very simple actually. If you understand kuti route ratio, what's really happening, you just have to follow command to configure route rako. Configuration example. Looking at this example, we have a static route panap so that we get to this network irapa 2110. So tunosvika sei ipapo route redu rinoiswa the destination network and the subnet mask ndosvirapa then ish inext hop. So kana ndichida kusvika panapa ndinoshandisa next hop irapa ishi from this device 10002 ndo irapa. Or if I'm using my exit interface kuti ndisvike panapa ndinobuda neapa ndo irapa. No. Is it different? I think this is another example. Configure RTC. I think we are configuring this one to get to network 10000. Where is 100 here? I think to get to this network here. For us to get there from RTC, exit interface here, then get serial 100 do irapa. I was thinking SR Panap, but it's a bit different. So that's how you configure Maraos Argo. Another type of route, Latinaro default route. I've already mentioned this. It's a route. It's a route which is used to forward packets when they do not match any routing entry in the routing table. So let's take a look at this example. RTA needs to forward packets to a subnet that is not directly connected to it and forwards the packets to 10.0.0.2. Okay, let's have an example. Kuna RTB 10.0.0.2. How do we have an example here? Right, let's have an example. Para RTA, routing table ish. My routes ese to these networks aripo panapa. So routing table in my routes ese are configured aripo either statically or dynamically aripo. To add to that, pane this default route configure. Packet rikauya pana RTA redestined for 192.168.10.0/24 network. Ikaenda tariswa murouting table ichashayikwa. Why? Because murouting table mune networks aya. Mune aya zoma directly connected aya. Irapa. But iya himwe. So RTA inoita sei? Inoshandisa this default route. Default route it matches everything, anything. Saka packet redestined to this rinoshandisirwa this route rovhura forwardwa kuenda ikoko. So you see kuti iri richaforwardwa via this next hop rosvitswa panapa. Kakawanda kacho panapa pane interface inoenda kuinternet. Saka router iri parinotarisa packet redestined for this rinotarisa routing table. Rikatarisa routing table richashaya match. Rashaya match default route repanapa rovha ranongedzera kuinternet. Packet rovha ranodonedzerwa muinternet. Rikadonedzerwa muinternet, it will find its way in internet more. That's the perfect use default route. It's usually used kuti a packet rikashaya match, then rinoforwardwa out the interface reconfigured the default route. Application scenarios, internet. I've already mentioned that one. So I think this is an application scenario. Panapa ndo paiswa default route redu. Saka pakauya packet rinoshayikwa murouting table iri rinoforwardwa out to this next hop irapai next hop ishi rikangosvika panapa robva rapfekerwa kuinternet. Kuinternet ikoko rinowana match. That's an application scenario ye default route. Then to end up a dynamic routing. I've already mentioned my static routes having a disadvantage. Yekuti they do not update. In an example, yekuti link radhakwa. Link rikadhakwa, static route inoramba iri routing table. Haibvi. So you will need to manually change that. Unlike my dynamic routing protocols, they automatically discover and update my routes depending on protocol yaunenge uri kushandisa. So for small networks, yaunokwanisa kumanage easily, static routing very preferable. But for bigger networks, yekuti maroutes akawandisa, you do not manually configure all those routers. You cannot monitor all those links. It's much advisable kushandisa ma dynamic routing protocols. Dynamic routes can be automatically discovered and learned. Dynamic routes can adapt to topology changes. So ukaisa static route parouter rino, uisa static route rinosvitsa kunetwork iyi. Link iri rikadhakwa iri oro rino rikadhakwa iri, route iroro rinoramba ririmo mutable. Static rinoramba ririmo. That's a problem because every packet rikasvika panapa riri destined to this network, rinenge richingoiswa muroute riri static iro. Rikaiswa imomo rikasvika kunoko, it gets dropped. But kana tine marouting protocols, link iri rikadhakwa iri, router iri rinoupdatewa kunzi link rakadhakwa saka chimboshandisaiwo this path muende nekunoko munosvika. That's the idea. Classification. My dynamic routing protocols can be classified by application scope. We have IGP, we have EGP. When we talk of IGP, these are protocols that are used within a single AS, autonomous system. So for example, single campus network yenyu, campus network, an internal network, munoshandisa interior gateway protocols, enterprise network pa company penyu. Kana makuda connect a company yenyu via service provider to another company, makushandisa exterior gateway protocols, BGP. We can classify my dynamic routing protocols by working mechanism and routing algorithm. Number 2, we have my distance vector routing protocols, which share their routing tables to each router, and they share the distance and the vector yema routes. So distance ndambatara nyaya hop count. Kuti ndisvike destination ndichafamba mumarouters mangani. Ndo distance yo. Ndakananga nekupi ndo vector. So classification by working mechanism, we have my distance vector routing protocols. The other one, we have my link state routing protocols, which makes use of my link state databases, where a routing table maps the whole topology yenetwork yese. So every router rinenge rine database rakafanana in the whole network. Router 1, 2, 3, ASL my routing tables. Let's say my database, not my tables. My database akafanana, meaning my updates anoiswa pamarouters ese to an extent yekuti every router rinenge rikuziva kuti network yese yakamira sei. So ndoinonzi malink state routing protocols. Example, ndoye OSPF. I think much of our learning will be focusing on OSPF EO. Route recursion. A recursion is a recursive search process of the IP routing table where the next hop IP address is wanted to route packets towards its destination, but when found, it is not part of any directly connected networks. Right. When we talk of recursion, it's a case yekuti we have multiple lookups to the routing table, usually caused when a route uses a next hop IP address instead of a directly connected interface to get to the destination. Example, we have a static route Ripanapa here that allows us to get to this destination network via this next hop IP address 20, this one. Right, I think it's from RTB. Let me see. 30120 EO 2113. Is this not from RTB? This should be from RTB, this one. Okay, it's actually from RTA. I think that is what defines a recursion here. Let me see. Let me see if I can get this. All right. In this example, you can see could RTA in a route irrabe. So if I want to forward traffic to this destination from RTA, ndichatarisa the next hop. Ndatarisa next hop ndoona haipo pama directly connected interfaces. Pana next hop haipo. Then I will need to have another lookup. Is this correct? So that I can find a directly connected interface. This is not correct. It's not making sense. Yeah, they got to correct when Huawei technologies are. It's not making sense. Route recursion. J. Explain that one. This is not making sure for me. Give me a minute. Nimbotere break. Meanwhile, to explain it, I want to route recursion up. In my head, it's not making sense. Just a minute. Someone I'm going to take over route recursion. Prove what is it. All right. The next hop of the route 30 is 2113. If the IP routing table does not have a route to 2113, This static route does not take effect and cannot be installed in the IP routing table. So what happens? Recursion. Configure a route to 2113 with the next hop pointing to 10. Well, it's not making sense. On the directly connected network. RTA can recast the route with the destination 3112 to the route with the destination 10002. I think it now makes sense. Right. Route recursion is a search process of IP routing table where the next hop IP address is wanted to route packets towards its destination, but when found, it is not part of any directly connected networks. So in this example, I think route repo, let me remove this. Right. In this example, we've configured a route irrabe pan RTA. However, route iroro, it won't be installed. Why? Because if I want to go to this network according to route RAM, next hop IP irrabe is not part of directly connected interface. Exit interface in the network irrabe. The next hop is not there. Under normal circumstances, the first route raunotoisa is 30, 1, 2, 0, 24. This is the mask. Then also next hop irrabe 10, 0, 0, 2. Packet rako rinobva rasvika panapa. Then panapa poita rimwe route rina 30, 1, 2, 0 neexit interface iri 2, 1, 1, 3. So inonzi route recursion is a case yekuti uruda try kuinstall a route, but the next hop IP is not on a directly connected interface. To solve that, ndosaka tine iro ndoinonzi route recursion yacho iro. So what will happen kana ndoda kusvika ku 30110 ndinotanga ndatarisa route iri. Actually ndinotanga ndatarisa less than a minute. Ndinotanga ndatarisa iri ndori kundisvitsa kuna 30, but next hop yangu is not directly connected. Then I have a second look ndotarisa rimwe route iri riri kundisvitsa papi pana 2113 rovha randibudisa nepana 10002. So ndichabuda nepana 10002 up kuti ndisvike pana 20 up. Ndikasvika apa, then ndo inonisvitsa to the destination network. Let's have last session. I think this one will be much smaller, probably 15 minutes to continue there. Same link, proper explanation next time.